The next topic after evaporation and transpiration, that means we have one more loss other than evaporation, transpiration and evapotranspiration, that we call it as infiltration. What do you mean by infiltration? Infiltration means the property by which water seeps into the surface stratum of the earth. That means some portion of water, it gets seeped into the surface stratum of the earth, not into the subsurface. That means whenever it's going to into the subsurface, we call it as seepage. That is going to join the groundwater. That is different. And this infiltration means the property by which water seeps into the surface stratum of the ground level. That means surface stratum of the earth level, which we call it as infiltration. And infiltration is measured by using infiltrometers or rainfall simulators, and we have an important equation, very important equation, especially in GATE exam point of view. At least from the last 10 years, 15 years analysis, at least once in 2 years, you can expect a question 100% on infiltration by using the equation so called Horton's infiltration equation, or we call it as Horton's curve, which is very important in GATE and ESE exam point of view. On infiltration, we call it as Horton's curve or Horton's infiltration equation, which states Horton's curve is nothing but a plot of infiltration versus time. That means I am taking it like Horton's curve is this. It's a plot of infiltration versus time. Infiltration versus time. Initially, you will be having, whenever the rainfall started, the infiltration will be maximum, and slowly it decreases exponentially, and finally it's not going to become zero, it's going to become a constant value. So initial maximum amount of infiltration, we can write it as F naught, and finally it's going to become a constant value, we can write it as Fc. Therefore, initial infiltration is F naught, final infiltration is Fc. And one more thing is, infiltration is expressed in terms of mm per hour or centimeter per hour. That means the units of infiltration and intensity of rainfall are the same. Therefore, and how in this Horton's curve, we can calculate the infiltration at any time t. That is, I am taking some any required time t in hours or t in days. Now we have an equation by using Horton's curve, that is Ft is equal to, that means infiltration at any given time t is equal to, see this is your constant infiltration, so I am taking it infiltration at any time t, that means it's nothing but an addition to this Fc. Therefore, I can write it as Ft is equal to Fc plus, and since this is reducing exponentially, we can write it as F naught minus Fc, that means this value F naught minus Fc into e to the power of minus kt. We are using e since it's reducing exponentially by using Newton's law of decay, where k is the constant of degradation or decrease, and t is the time in hours. When you have the t in hours, k should be 1 by hours. When you have the t in days, the units of k should be 1 by days. So this equation, Horton's curve equation, is very important equation in GATE examination point of view, on which you can expect a question 99.9% almost in every year in GATE civil engineering stream. And apart from the Horton's curve, we have one more chance of problem which is very important in GATE, especially in ESE also, that is how to measure the infiltration by using infiltration indices. That means infiltration is measured by using infiltration indices. We have two kind of indices, so called phi index, W index. So phi index means we take phi index as PE minus R by TE, where PE is the effective rainfall. Effective rainfall means the rainfall that is contributing to runoff, where in W index, we are taking it as P minus R minus initial losses by T, where P is the total rainfall and T is the total time that the rainfall is occurring, and initial losses also we need to account for. So all these things we have. So I can write phi index is equal to PE minus R by TE, where PE is your effective rainfall, TE is the time that the effective rainfall is occurring, whereas W index can also be called as average index or average infiltration parameter, that is equal to P minus R minus losses by T. So in this you are also considering the initial losses like infiltration, evaporation losses as well. But I want to tell you, infiltration is the major loss among all the other losses or abstractions. So sometimes, mostly in the phi index, we assume all the other losses other than infiltration to be very small and therefore can be negligible. So in this subject, other than Horton's curve in infiltration, phi index, W index, you can also expect very frequently in gate exam point of view. So this ends up a topic so called infiltration, as well as this also ends up our abstractions. We have various kinds of abstractions like interception, evaporation, transpiration, evapotranspiration, infiltration. So the rainfall which is coming from the atmosphere after resulting in all the losses as we mentioned till now, finally leads to net rainfall. That means after meeting all the losses, the rainfall whatever is left, we call it as net rainfall. Net rainfall can also be called as runoff.